This video should help you with section 4. We learned to apply radicals to Pythagoras' theorem. You've probably heard of Pythagoras' theorem again. You've probably heard of Pythagoras' theorem before, which involves the lengths of the sides in a right-angle triangle. So if I use this triangle here, there's a right angle. Across from the right angle is the longest side. It has a special name called the hypotenuse. And if I take the legs of the triangle, the other two sides, the shorter ones, and square them each and add them together, you always, provided it's a right angle triangle, you will always get the length of the hypotenuse squared. So that's Pythagoras' theorem. You've probably seen that before, but we're now going to use it with radicals. Rather than coming up with decimal answers, we might end up with a radical answer. Please excuse the messy triangles. They're kind of hard to draw really quickly with this program. So I hope you will trust that this is actually a right angle triangle, even though it doesn't really look like 90 degrees over there. Okay, so here I'm going to find the hypotenuse, the longest side. So I can take 3 as one of the legs and 7 as the other one. So I take 3 squared plus 7 squared, and that's going to equal the hypotenuse squared. In this case, it's x rather than c. Okay, we work that out. 3 squared is 9, 7 squared is 49. That's equal to x squared. And 9 plus 49 is 58. Equal to x squared. And then I square root both sides. Officially, when I square root something, I should get a positive and negative answer, but we're going to ignore the negative answers for right now because it's a length and I know that's not going to be negative. So I get the square root of 58. Before I go on, I should look to see if I can simplify that any further. So we have to look for perfect squares. Is 50 divisible by 4? No. Yeah, 56 is divisible by 4, and 60 is divisible by 4, so 58 is divisible by 2, but not by 4. 9? No, 54 would be divisible by 9, so we've ruled out 4, ruled out 9. What comes next? 3 squared 4 is 16. Well, 4 doesn't go into it, 16 is not going to. What about 25? Now that goes into 50, so not 58. And if I go up any further, 36, 36 doubled is already higher than 58, so 16. So as soon as I've gone beyond that, I know there's no perfect square in 58, so this is my final answer. Okay, let's try another one, where the thing we're trying to find is not the hypotenuse, but one of the legs of the triangle. Let's make this 2, and this x, and this square root 8. And maybe there's even units on here. Let's say they're centimeters. This is not to scale. The 2 centimeters doesn't look that much shorter than square root 8. Well, maybe that, yeah. Hard to tell. I don't think it's to scale. Okay, in this case, we're looking for one of the legs, so I have to set up the formula a little differently. Instead of it being equal to x squared, I have to have the x at the beginning because it's one of the legs. Or it could go in the second place. I could do x squared plus 2 squared, which I'm going to do here, or I could do 2 squared plus x squared. Adding the order doesn't matter, so you can do it either way. And that's equal to square root of 8 squared. So x squared stays as it is. 2 squared is equal to 4. And square root of 8 squared, remember, any square root squared is always equal to the number under the square root. Okay, from here I subtract 4 from both sides and get x squared is equal to 4. So now when I take the square root of both sides, I get x is equal to 2. And since I was measuring in centimeters, I can add centimeters back on too. Okay, that one worked out perfectly. I didn't have a square root like this. If I had had a square root, let's say your answer ends up being something like square root 12, then don't forget to look for the perfect squares. 4 is a factor of 12, so I would do the same thing that I did in chapter 3 and make this square root of 4 times the square root of 3, and then square root of 4 is equal to 2, so the 2 comes out of the radical sign and the 3 stays underneath. Okay, so remember that little step, looking for answers that are radicals. Okay, one more example and then you're already set to do section 4a. Let's say I have 2 unknowns, but they're the same. An x over here and a 2x here for the hypotenuse. Make sure you identify the sides correctly. This is the longest side, so that's the one that's going to go all by itself squared, and these 2 squared have to be added together. So x squared plus 6 squared equals, and before I do 2x squared, I'm going to put it in brackets because the whole side has to be squared. An important point here is if I just write this, that's not the same as this, because the exponents only apply to the thing right before it. So this is 2 times x squared, which is 2x squared. I can't simplify that any further. But this means 2x times 2x. Right? This side is 2x. I have to multiply the whole thing. I can't just take part of it and multiply x by x and then by 2. I have to multiply 2x by 2x. So this side actually gives me 4x squared. And that's why those two things are not equal to each other. So make sure you use brackets if your side is a bit of algebra like that, to make sure that you square the whole thing. Let me get that out of the way. Okay, so simplifying the equation, I have x squared plus 36, and I already calculated this down below. That makes 4x squared. Okay, I have 2 variable parts here and here, so I want to get them on the same side of the equation to begin with. So let's subtract the smaller one. Subtract x squared from both sides. And I have 36 over here and 3x squared over here, subtracting like terms. Then I'm working backwards, so if I would multiply this by 3 to undo it, I have to divide by 3. 36 divided by 3 is equal to 12. And 3 divided by 3 is, of course, 1, so that's just x squared. And lo and behold, I end up with the answer that I wrote up there. X is equal to square root 12. So we're going to split up square root 12 into square root 4 and square root 3. And then square root 4 is equal to 2, and square root 3 stays square root 3. So x is equal to 2 square root 3. And that means this side is equal to 2 square root 3, and this side would be equal to twice that, so that would be 4 square root 3. And that's the final answer. Okay, bit of review of Pythagoras' theorem, but keeping in mind all of the things you learned about radicals in chapter 3. And you're ready to do section 4a.